Hello AV Calculus students. We are working on 2018 question number 2. It's a position, velocity, acceleration question, and it also is a calculator question. So the first thing I did is they gave me a particle. They told me its velocity, and I took the velocity and put it in y1 in my calculator. I also wrote this down here. There is some second particle, and so I just wrote it down. So the second particle, they let you know that by putting a little 2 there. Okay, so this is calculator question, and let's go ahead and see what we got to do. So part A, it says find the acceleration of the particle at time equals 3. Well, you need to know to get from position to velocity, you take the derivative. And to get from velocity to acceleration, you take the derivative. Now, could you take the derivative of this by hand? Yes. However, we have a graphing calculator. So for this problem, I'm going to do the derivative. Now, instead of dt, since it's my calculator, math 8, take the derivative of, and instead of typing this whole equation, I did put this in y1 in my calculator. So I'm going to use the hotkey y1. Okay? But instead of the hotkey y1, you can just type the whole equation, and then when x is, instead of t, when x is, they wanted to know the acceleration at time 3. And if you do this, you'll get the acceleration at time 3 equals, and I'm just looking it up, negative 2.118. Now, if they gave you something like this on the test, they could actually ask you to find the equation of acceleration. And that's something they could do. So if they said to find the equation of acceleration, you'd have to do low d high minus high d low over low low. We don't need to do it for this question, but it might be on your AP exam. So I want to make sure everybody knows. So if we had to do that, we would say low d high. I need to know what's the derivative of 10 sine u. Well, the 10's a constant multiplier. It just stays there. And the derivative of sine u would be cosine u times chain, and the chain being the 2 would go to the front, 0.8t. So that's the low, that's d high minus the high, so I'm just going to copy the high down, d low. The derivative of the low is 2t minus 1. And I'm going to put that in parentheses to make sure everything belongs to it. And then all over low low. So I'm just going to copy down the low, and low low means the denominator squared. That would be the quotient rule. Low d high minus high d low over low low. And again, if they didn't ask for the acceleration at time 3, if they just said, hey, find acceleration, you'd actually have to do this. And they could make you do that on the test. Just to see, hey, do you know quotient rule? And no reason to simplify that. Anyways, that's part A. Part A was done right here. I just showed you the extra, just in case you might need it for the exam. All right, let's go to part B. Part B, they say find the position of the particle at time equals 3. So we want to know where's the particle at time 3. And good news is we know where the particle is at time 0. The reason this is so important is, remember, if you do the area underneath velocity, let's say the area underneath velocity from time 0 to 3. Remember what happens. The first thing you do is you take the antiderivative of velocity, which is position. Of course, instead of s of t, we could write it as x of t. And then you would plug in the top and the bottom and subtract. And you'd get x of 3 minus x of 0. And as you can see, if you rearrange these, if I added the x of 0 to the other side, I would get the position at time 0 plus this would give you this. So anyways, this whole idea, the area underneath velocity gives you net change in position, is what we utilize when we look at things and we say, all right, which one comes first? 0 or 3? 0 comes first. So this is the initial. We're trying to find what's going on at time 3, so this is the final. And again, final is equal to the initial plus the net change. So we need the area from 0 to 3 underneath velocity. Very easy question, because we know the initial is negative 5, so it's negative 5 plus whatever I get here. And again, I have a calculator. This one you couldn't do without a calculator. You can't take the antiderivative of that by hand. And if you type all this in the calculator, you get negative 1.760. There's more decimals. Give me 4 decimals, but we can just stop there. So that was really easy. Initial position plus net change in position is final position. This question is actually a very easy question. All of it. All right, let's go to part C. Okay, so for part C, they want to know, what does this equal? So this. And then what does this equal? Now, these questions are just simply typed out on your calculator. That's in Y1, so I'll use my hotkeys alpha trace, hotkey alpha trace. Remember the absolute value. You hit math, you go over 1 to numbers, and then it's right there at ABS. So math over arrow 1, and then there's your ABS. Anyways, if I type both of those in, I get 2 different answers. This first one, I'm just going to copy it down. 2.843. And the second one is 3.737. Again, since I'm copying it offline, I'm not taking the time to do it in front of you. I'm only giving 3 decimals because that's what they give you online. Give 4 or more decimals always, and you never have to worry about rounding, and you can't screw up. All right, so besides the answers, they need you to tell what they mean. The big difference is if it's just velocity, it's displacement. And if it's the absolute value, we have total distance. So you would say this is the displacement, but you always need to talk about time. So from time equals 0 to time equals 3. And this means the total distance traveled. So again, is the total distance traveled from, and you got to talk about time. Time equals 0 to time equals 3. Again, part A, B, and C, easy, easy, easy. We like this. Some quick points, and now we're going to go to part D. All right. Part D, a second particle moves along the x-axis with its position given by this. At what time are the 2 particles moving at the same velocity? Insanely easy question. We want to know when they have the same velocity. You just set the 2 velocity equations equal to each other. Now, what do I mean? Well, I can take this particle right here and take its derivative, and I get the velocity of the second particle. The velocity of the second particle is simply 2t minus 1. That's the velocity of the second. That's the velocity of the first. All we need to know is when are these equal. So if we can find out when is this velocity, equal to this velocity, we win. And all you need to do, there's a couple ways of doing this, but you can simply put this in y1 in your calculator. I already have it there. And this in y2, and then graph. And wherever these 2 graphs meet, their intersection is the solution to this equation. So if you graph both of those, you will get the answer. Oh, let me scroll down. 1.57. 1.57054. And that's it. You're done. The only other way of solving this is you could have subtracted all these to the other side, and then you'd get minus and then a plus 1 and set it equal to 0. And you could graph it all in y1 and find the zeros. And again, that was part D. And that A, B, C, and D, probably the easiest question you've seen in a while if you remember these problems. All right, have a good day. Bye.